Welcome back to The Explainer. Today, we are diving into the sheer, fascinating 70-year evolution of modern AI. We're going all the way from the earliest kind of wild dreams in the 1950s straight through to today's massive breakthroughs. We're going to trace the huge leaps, the totally surprising accidents, and the literal mechanics that brought us from simple text parlor tricks to machines that can actually simulate human reasoning. Let's get right into it.
Here is our roadmap for today. First, the birth of AI. Second, the illusion of conversation. Third, brute force beats Kasparov. Fourth, attention is all you need. And finally, the unexpected emergence of reasoning.
Section 1. The birth of AI. So if we step back and map this out, it's just fascinating to see the major leaps in computing eras. We're starting with those foundational, big-picture ideas in the 50s, moving to some very early chatbots in the 60s, witnessing the absolute brute force power of the 90s, and then boom, we hit the modern paradigm shift in 2017.
You really have to appreciate the sheer audacity of early scientists like John McCarthy and Marvin Minsky. Just look at this 1955 quote from their proposal. They asked for a 2-month, 10-man study, and they genuinely thought they could make a massive dent in solving artificial intelligence in a single summer camp. The underlying belief was simple. If a machine could do a job, well, an automatic calculator could just be programmed to simulate it. No big deal, right?
Moving right along to Section 2, the illusion of conversation. Now jump to 1966 with a program called ELIZA. Here's the thing. ELIZA didn't actually understand a single word. It just followed these extremely clever mechanical steps. The program basically scanned whatever you typed for specific keywords, completely dismantled your sentence based on hard-coded rules, and then reassembled it into a brand new output. It was an ingenious pattern matching trick to basically sidestep the massive, nearly impossible problem of teaching a computer real-world knowledge. To see exactly how this trick played out, we have to look at Weizenbaum's specific script called Doctor, which was designed to mimic a psychotherapist. If you typed, "You are very helpful," ELIZA just swapped the pronouns from "you are" to "I am" and plugged the rest into a pre-written question format. It literally just flipped your own words right back at you, asking, "What makes you think I am very helpful?" But wow, the result was a surprisingly powerful illusion. These responses were so convincing that people actually became emotionally attached to the program. It was so intense that Weizenbaum's own secretary asked him to leave the room so she could have a private chat with the machine. This accidental psychological discovery became permanently known as the ELIZA effect. And this is absolutely crucial because it proved that the barrier to making a machine seem human was way, way lower than anyone initially thought. As humans, we just naturally project deep meaning onto totally superficial machine responses. All right, Section 3, brute force beats Kasparov. 200 million. To put that into perspective, that is the exact number of chess positions the Deep Blue supercomputer could evaluate every single second. This wasn't some lightweight program. This was a massive IBM supercomputer taking up 2 entire cabinets, relying completely on raw, staggering computing muscle. Unlike the AI we use today, Deep Blue did not learn on its own. It was what we call an expert system. It relied on custom-built chess chips and an opening book crammed with hundreds of thousands of grandmaster games. Its evaluation function alone had 8,000 different parts designed by literal human chess experts. It achieved victory through an alpha-beta search algorithm. And what that essentially means is, it just calculated every possible path rather than developing anything resembling true human intuition. But here's a fascinating twist of fate. During the 44th move of their first 1997 match, a simple software bug forced Deep Blue into an unintentional loop. So, as a fail-safe, the computer just picked a totally random valid move. Garry Kasparov, the reigning human champion, completely failed to understand the move and misattributed it to some kind of superior hidden intelligence. He got completely psyched out. It hits the nail on the head regarding the ELIZA effect we just talked about, showing exactly how easily we project brilliant strategy onto what was, literally, just a machine error. Which brings us to Section 4, attention is all you need. Okay, so before 2017, language models used things called recurrent neural networks, or RNNs. They painfully plotted through text sequentially, literally one word at a time, and often ended up forgetting the beginning of a paragraph by the time they reached the end. But the new transformer architecture totally changed the game. It looks at all the words at once, treating language not as a linear timeline, but as a spatial field of meaning. This made it wildly faster and highly parallelizable on modern hardware. The real secret replacing that sequence is a mathematical mechanism called self-attention. Think of the sentence,
The animal didn't cross the street because it was too tired. Now, to us humans, it obviously means the animal, but old AI really struggled with that. Self-attention lets the model mathematically figure out which other words in a sentence are most relevant. So it allows the AI to heavily focus on the word animal when evaluating the word it, freely drawing connections across the entire text.
Let's dive into how this magical mechanism actually works. Every single word is turned into a vector, which is basically a list of numbers, and gets assigned three distinct roles: a query, a key, and a value. Imagine the word she. It acts as a query, asking, hey, which earlier word do I best match? Meanwhile, other words offer themselves up as keys. When the math finds a match, the value is passed on. So every single word is constantly interacting with every other word to figure out the grander context. It's like a giant instantaneous puzzle. And finally, Section 5, the unexpected emergence of reasoning. Now, perhaps the absolute most surprising part of this whole shebang is that the original 2017 Google Brain paper was just trying to improve language translation and computational efficiency. They weren't even aiming for reasoning or common sense. But when researchers took this transformer architecture and scaled it way up, training it on massive amounts of data to simply predict the next word, an entirely unexpected phenomenon emerged. The model started handling complex analogies, completing logic puzzles, and making deep inferences. It turns out predicting the next word over and over forces the model to internalize the deep logical structures of human language. It's honestly like teaching a child nursery rhymes and discovering years later that they can write Shakespeare. No one expected it, but it absolutely ignited the modern AI boom. So I want to leave you with this profound thought about our future alongside machines. If an AI can accidentally learn to reason just by playing a massive game of fill in the blank, what does that mean for the unique value of human intelligence moving forward?